Good morning. This is A. Deepika, Assistant Professor from the Department of Artificial Intelligence and Data Science. Today, the topic we are going to discuss is A-star search algorithm. So, basically, A-star search comes under the informed search algorithm. It's mainly used for finding the shortest path to reach from the starting node to the goal node. It calculates the shortest path by calculating two different values, that is value of g and value of h. The value of g is calculated based on the distance from the starting node to the current node, and the value of h is calculated based on the distance from current node to reach the goal node. And for every node we need to calculate the g of n and h of n. By adding these two values will give the cost function for that particular node. This is the steps we are going to follow to find out the shortest path in A-star algorithm. As we have already seen, we need to start from the starting node point. From the starting point, we need to calculate f of n value for every node that can be visited from the starting node. So the node we are going to visit will be in the open list, and the node we have already visited and calculated the f of n value means it will be in the closed list. This is the problem we are going to discuss in today's session. As we have seen, the problem will have the 6 number of nodes, that is S, A, C, B, D, Z. So we are going to find the shortest path from S to Z based on application of A-star search concept. So as I already told you, it's an informed search means every node will be assigned a heuristic value to it. So the value of heuristic function S is 7 and A is 3, B is 4, C is Z, D is 5, Z is 0. Okay, because Z is the goal node we are going to visit, then it has the h of n value as 0. First step we are going to do is we need to explore from the starting node. For this graph, the starting node is S, right? From S, what are all the nodes we can visit is A to Z, right? S to A and S to Z, we need to first calculate the f of n value. For S to A, we have f of n is equal to g of n plus h of n. So, g of n value is what? The distance from starting node to the current node, right? So, g of n value of A is 1 plus h of n values from the table. What is the h of n value for A? 3. So, 1 plus 3 is equal to 4. This is the f of n value for S to A. Okay. Then we are going to apply the same for S to Z. So, the distance from S to Z is 15, that is g of n, plus h of n value from the table is 0. So, 15 plus 0 is equal to 15. Okay. So, when finding out the cost for S to A and S to Z, we can easily understand which has the lowest cost path, right? So, to explore further, we need to choose only the node which has the lowest cost path. So, we are going to explore from S to A. So, the next node we are going to visit will be from A. From A, what are all the nodes reachable? A to B and A to C, right? So, S, A, B and S, A, C. This is the path we are going to calculate the cost function now. So, for SAB, the cost function we are going to calculate, we need to note a point. To find out the g of n value, we need to calculate the total cost path from S to B. So, 1 plus 2, 3. So, 3 plus h of n value is what? 4. 3 plus 4, 7. And the same goes for C. To calculate the g of n for C, what is the definition for g of n? The distance between starting node to the current node, right? So, to calculate g of n for C means the distance between starting node S to the current node C. So, what is the path cost? 1 plus 1. So, g of n value for C is 2 plus h of n value is 1. So 2 plus 1, 3. So compared to SAB and SAC, only SAC path has the lowest cost function. So now we are going to pick that particular path to explore further. So from C we can reach both nodes, that is D and Z, right? So SACD and SACZ. So the G of n value of D is what? Distance from S to D. So 1 plus 1 plus 3, 5. 5 plus H of n value for D is from the table 5. 5 plus 5, 10. And then for Z, the distance to reach from S to Z is 1 plus 1 plus 3, 5 plus 0, that is H of n value. 5 plus 0 is equal to 5. So as you have already seen, in this path we have visited from the source node S to the goal node Z. So basically we can select this is the final shortest path with the cost value. So these are all the applications, that is A-star search can be used for NPC pathfinding in gaming development and also for navigating purposes in robotics, autonomous vehicles along with the Google map. So while it has the advantage of its own, it also has the limitation. Basically it easily find the shortest path with the minimum computation effort, but at the same time we need to find the cost function for each of the nodes, right? So it has the high memory usage. And we have the heuristic function, right? So based on the heuristic function only we are going to calculate the total cost for every node. So we need to accurately find the heuristic function for every node, otherwise it will give them inaccurate result. Thank you.